chlorine. This is my model of the element chlorine. Chlorine has an atomic number of 17. In my model of chlorine, the dark blue beads in the nucleus represent the protons. As you may see, there are 17 protons in the nucleus of chlorine. The other particle in the nucleus is represented by the light blue beads. These are the neutrons. In this isotope of chlorine, there are 18 neutrons. The neutrons added to the protons equals the mass number, and the mass number of this model is 35. The atomic mass is different than the mass number. The atomic mass is the average of all the isotopes of chlorine, and the mass number is only one isotope. There are a total of 17 electrons in this atom. There are 2 in the first shell, 8 in the second shell, and 7 in the third shell. As you may have noticed, the number of electrons is the same as the atomic number of my element chlorine. That makes this a neutral atom because the number of positive protons and negative electrons is the same, so they balance each other out. Chlorine is in the 7th period or row on the periodic table, so it has 7 valence electrons. If you look at these numbers in the corner, they also show the number of electrons in each shell. Chlorine is in group 17, which makes it part of the halogen family. The halogen family consists of fluorine, bromine, iodine, acetine, and of course chlorine. They all share their number of valence electrons, which is once again 7, along with other characteristics. All members of the halogen family are reactive and found in the Earth's crust and dissolved into ocean water. It is the only family of elements that range from being solid, liquid, and gas at room temperature. As you can see on my periodic table, chlorine is a nonmetal. It is a gas at room temperature. To find chlorine's density, look at its position on the periodic table, since it's near the top. Then look at the number of protons, 17. This makes chlorine's density low. Another way to tell what the density is by the size of the nucleus. Thus, chlorine's nucleus is small, so it has a low density. Chlorine can bond in 2 ways. The first way is through a covalent bond. A covalent bond is formed when the valence electrons are shared equally between the 2 elements. This leaves all the elements bonding with a full outer shell. The valence electrons are held together by the force of attraction between the positive protons and negative electrons. Here's an example of a covalent bond using chlorine. Both atoms of chlorine have 7 valence electrons, so if they each share 1 electron, they will have a full outer shell of 8 electrons, which will make them both very happy. The second way chlorine can bond is through an ionic bond. During an ionic bond, the valence electrons are given away and received. This leaves both elements with a full outer shell. The force of attraction between the negative electrons and positive protons hold the atoms together. They form an ion. In this example of an ionic bond, sodium and chlorine are bonding. Sodium gives its 1 valence electron to chlorine, leaving chlorine with a full outer shell of 8. Wow, chlorine is so important. The name chlorine comes from the Greek root chloris, which means green. That fits because chlorine is a greenish-yellow gas at room temperature. Chlorine is very useful. It is a common ingredient used for sanitation and cleaning. It also cleans pools and drinking water. Chlorine is also used in bleach too. In addition, chlorine is also used in salt, table salt, and ocean salt. It is also very dangerous, so beware. When alone, chlorine is a toxic gas that irritates the skin, eyes, and respiratory system. Another significant aspect of chlorine is how it led to a major chemical discovery. The first chain reaction was a chemical chain reaction of chlorine and hydrogen in 1913, but wasn't fully explained until 1918. As you can see, chlorine is one of the most important and influential elements out there.